Hi, Bob.
I'm Chris.
Sam.
And we did something incredibly dumb. We made a programming language, and I'm going to talk to you about how part of what we did would only have been possible due to ClickHouse and some of what we did as well. But the whole point of why we made a programming language is because we've all seen LLMs, we've all seen AI, and that stuff never works. It's a really cool demo, but taking it to production is really hard. But wouldn't it be awesome if I could do something like this, and we'll see, fingers crossed, live demos, nothing here is recorded. So if it all breaks, I apologize. But I took that data and I turned it into this on the fly in real time, reliably. I'll do something else really fast. I'll take something more complicated. And fingers crossed, this should just work. But in theory, I hate AI demos because they're slow. Once the models get faster, this will be more fun. And we can pull this out now. And the beauty of this data is that it's structured, it's useful. And if you take a look at over here, there's some interesting data. This first trip is a Boolean. Over here, it's a checkbox. The Boolean's a whole lot more useful. Imagine I'm actually the country of Cambodia. I'm processing millions of these visas every time. I run this through the system, and now I have a database entry that I can look up. I do travel info dot is first trip, find everyone whose first trip it is, and make sure I have manually scanned those first with humans. Everyone else gets auto-approved, or as long as they exist in my database. This becomes a lot easier to do if we can get structured data reliably. The whole point of BAML is to make it so that these paradigms become possible. We've all seen this. APIs call. If ClickHouse went down 5% of the time, they will stop and fix ClickHouse right away. LMs call fail 5% of the time. We're all suddenly totally okay with that. We're what the heck? That should not be okay. We don't build software that way. We cannot rely on software like that. And that's why AI applications feel like jokes a lot of time, because we built them with this as an expectation. And the reason is fault tolerance is incredibly hard. We're in this beautiful building by Amazon. They spent decades building fault tolerant systems. And they had to do that because they had to rethink how web development happened if you were just to care about fault tolerance. And because they did that, we can have companies like Netflix built on top of that. Now, the problem is with AI, every piece of software has to be fault tolerant. How do we think about that? The same thing used to be true in websites. Can you guys see that? How many of you wrote a website like that before? Anyone? Anyone not have written a website like that before?
I see at least one person nodding their head.
If you haven't written a website like that, that's probably because you're writing a website like this. And the syntax is something beautiful for us. It allows us to infer what's happening in a way that's readable for the developer and lets the compiler do beautiful things for us. We set the count every time we click the button, and React magically re-renders this component. I forget to put this closing div over here. I get a beautiful squiggly line that says, do not push this code to main. I forget the squiggly line here. I push the main and my website breaks. That's the difference between what this syntax was able to do for us. What it was able to do is able to take a world where everything was strings and remove that. Everything stopped becoming strings. It became fragments, JSX fragments. It took a world where state management was hard and fixed that. Allowed React to handle the state management and the interactions of how updates happen on state and made that easier. Dynamic components. When I was first graduating from college in 2012 to 2015 kind of era, there was this really hard interview problem. Make an infinitely scrolling website. That was a serious problem. Now in React, you can just do that the first time you're doing it because it's just simple state management with pagination. Reusable components. Websites used to look like GeoCities for a reason. Reusing components was really hard when everything was a string. And then I think the most important part that people don't realize is how much faster we got at writing code and websites once we got hot reload and component re-rendering. Because instead of having to compile your entire backend, send over the entire page, lose all the state, I change one component, my state around it stays the same, and that component hot reloads. Change the code, Command S, look at the browser, and it works. The way I put it is React added something that we all engineers love, engineering rigor. Now, how many of you have written a prompt that looks something like this? Anyone? Anyone not having written a prompt like that? Anyone have beautiful prompts in their code base? Okay. The thing is, these problems are really, really similar to React. You have strings everywhere. Context management is really, really hard to deal with. And if you change one thing, everything downstream somehow breaks. And most importantly, your iteration loop takes so long. Somehow you have to figure out the right prompt and hope everything downstream will work. And iterating on that is just too slow. Same problem, engineering rigor. What we really want is something that allows us to express ideas like English, but still maintain the structure of code, because code is beautiful. HTML was English, React was code. And we want to bring that somehow to the world of agents. We've all seen these frameworks, probably. And there's this funny blog post called FU Show Me the Prompt. Try finding your prompt out for a model. It's very, very hard to find your prompt anytime you're writing abstraction, even if it's your own in-house abstraction. And that's like writing React, but not having access to the HTML that it produces. You can't debug it. You need to know the prompt to go do this. So what does this all really mean? And I'll show you in 1 second. Switching windows is hard. I'll show you how we approach this kind of problem. So we write everything as a function. Functions take parameters. Functions return data models. Data models are defined in code. Then you write what model you want to use, and you can use any model of your choice. Then you write your prompt. Then you write test cases. This is the most important part. You write test cases. Actually write your tests. But I think the part that really helps is like React. We give you a hot reload loop. As you type your prompt changes. You can see it update. As you change your inputs change. But once you're ready to, you can actually run your tests. And when you run your tests, something nice happens. Models are horribly unreliable. So the model in this case adds in some backticks and some JSON, and we pull that out into your data model. We can do that because we have type information. We know what data type you want, so regardless of what the model spits out, we can guarantee that this type is going to be exactly what you want. Let's change this around for a little bit, and let's do something a little bit fancier. Let's say, don't use quotes around keys. Let's run this test. And now I got something that isn't JSON in any meaningful way, but we still pulled it out into your data model. Now, what if I wanted to split out name to be class name comprised of first last? It's completing it for me. Let's see what happens. It did it for me. It's expressing ideas like code in a way that a model can understand. But at some point, you're like, what the heck is this .baml file up here? How do I actually use this? Because I have an app that's not written in BAML. I have an app that exists in Python and TypeScript. You can actually take any BAML function you have, and I'll make a new one, and just use it in any language of your choice. And it's fully autocompletable. Import b, resume equals b.extract resume. I'll plug in some string into this. And then resume.email is a string, because emails are strings. Resume.experience is a list of strings. Let's go back to my code. Let's change this. Let's say I want experience to be an actual class. Experience, I don't want this. I just want role company. I change my code, and I do this. Now, my Python type also changes to mimic that. Now, you can do this in Python, TypeScript, Ruby, Java, whatever you want. So what we just did here is one thing. We're able to help you write prompts. We're able to help you write prompts in a structured way. We're able to guarantee that the model can respond in that, even when the model messes up. So really weak models can suddenly become incredibly powerful. You can use a 1B model in production, and they work. And on top of that, you now have type safety, which is, I think, useful. But at some point, all we've really done is helped you solve this part of the problem. We've helped you build and deploy your pipelines, because all of this is running open source, no servers, locally on your machine. But if we want to build an AI pipeline, we have to do all of these things. We're going to want to collect data on these systems. We're going to want to go ahead and know exactly which fields in the resume are performing poorly, which fields are performing well. We're going to want to be able to fine tune and do model distillation on these techniques. Maybe even write a heuristic instead of a model because we learned how we can go do this. And the worst part about this all is that machine learning is this horrific curse you're going to bestow onto your organization because it is this endless loop that will never stop. You will build your pipeline, you'll test them, you'll deploy them, and then you'll have to observe it and then figure out what's going wrong, update it, and do it forever. Because even if your pipeline doesn't break, and even if your models get better, your user expectation will change over time. They will drift from what you originally scoped out. And it's horrific. I worked on Face ID while I was at Google, and it's like one of the worst things you can have to deal with. You just have to collect data forever. The problem is that this is really, really hard to go do. It requires a lot of maintainability, a lot of data pipeline work, and a lot of prompt engineering, and any sort of arbitrary models as well that you might want to fine tune and train. The whole point of BAML is to not just help you build and test the pipelines and deploy them, but actually to help you complete the loop without writing a single line of code. And today, I think we're going to show you something that wouldn't have been possible if, one, we didn't have BAML, and two, if ClickHouse didn't exist. So, shall we show them?
Yeah.
All right, Chris. And I think we all like dark mode because we're developers, so we'll use dark mode.
Okay, so as Vaibhav was saying, this is something that we've all seen analytics databases. We've all seen logs, and ClickHouse obviously is filled with it, right? So what we did is we said, hey, we actually have the types that you can actually take out from your code, and we can pipe it all the way through into ClickHouse, all the way through our UI, and we can show you a list of every single LLM request that you make. And so now what you get, if you hover over this extract resume that he was just showing you, that's the function name that's actually coming from your code, right?
Sorry.
So this is the exact function. And you get the class name, and you get the types, and you see that, and you see the resume is now the input, and it's a string, and you see the output resume as a type, hovering over the type on the signature. You can see that the actual thing is we have the name, we have the email, we have the experiences. Right now it's a string, and the skills is a string. And then what we've done, which no other observability tool can do, which is we said, okay, here's every single one of these columns, and we can see exactly which ones in them, and in the type that they actually were processed. Nobody else can do that. So what we did is when you go and make a new LLM request, and you want to change that type, and you want to change that model, because this is your iteration loop, right? So, okay, this is great in production, you see all these logs, and now you're back in your prompt, and you're saying, oh, well, actually, this resume didn't capture my emails, or I now want to have a first and last name, right? And so you're now going through and you're saying, I want to actually now have my first and last name on my resume, and I want that to change, and I want to be able to see that in observability, not just in the VS Code extension that we have, but we want to be able to see this in real time, showing up into ClickHouse, out to the front end, in real time. And so not only does this help with development, but it also helps with production, right? So you're looking at your production database, your production code in here, as well as your development code.
So you can see over here that it's actually able to, right over here, name.first, name.last, just like my code. I wrote 0 lines of code. I just ran the code.
There you go. So yeah, so you see how we can actually extract things out. And as things get more complicated, right, like this is a very simple example, we can get into multimodal stuff, we can get into maps. If you look at these images, right, like we were showing at the beginning, like sometimes, you're doing multimodal stuff, you have audio, you have images. We can show that right in here and the exact actual image that you're going into, that you're passing in. So what's really cool is, remember how we were talking about those test cases that we were able to say, like, here's how we can have the iteration loop in our code, and we can have the test cases. We can actually go in here and we can say, hey, we actually love this one. This was a great output based off of the input that we have for this resume. And we can actually go in and we automatically create this test based off of the input where you can come in here and you can copy and paste this exact same test back into your code base. Soon you'll be able to run it in here. Right now you come back in here and you check it into Git, right? So now all your test cases are checked into source code, right? So everybody else can see them. You can see your commits over time. You can see when your LLMs start breaking, right? You've like changed the prompt and now all of a sudden your test cases are breaking, which no other, like you have to create like unit tests in Python and TypeScript and all this other stuff to be able to actually test your code, right? Like that is like, this is a non-trivial thing to do in LLMs today, right? And we can do this in your CI pipeline, right? Like we can do this all over, and now you have visibility through our tools to do that. And so then all you have to do is press play here in VS Code, and now you have that exact same prompt that you saw originally, which could be a production thing. You want to replay a production one. You want to replay somebody else's doing development on the same prompt. You can see the test case output of it. And then now you can iterate. You can iterate on the prompt. You can iterate on the types. And it just completes that loop for your entire workflow of building LLM apps.
So the idea is, the question we really started with asking was what happens when you add types? So TypeScript added types, and it changed how web development happens. My code base went from read-only and never touch this part of the code base ever again, never rename variables to make it more clear, to suddenly right-click refactor, right-click and rename, have maintainable code. In the AI world, we do need to go ahead and close this, as we all saw earlier, we do need to close this loop. So what happens when you add type safety to your data pipelines? Now, something new becomes possible once we're not only able to understand your types, but also understand what in your system is changing. So you see two numbers here that are represented. It's really nuanced, and this isn't super visual. But these two numbers represent, let me see if I'll just filter down to these specific functions. These two things represent something interesting. They represent two parts. The first part is, does my function signature change in any way? That means, do my types change? The second part is, did the implementation of my function change? So now you can have the same types with two different prompts and quickly understand, was it the prompt that made a difference or a type that made a difference? And you can not only version your code, but your data. But this enables a new thing that I think wasn't possible yet, and we'll see what this does.
So one of the things that is possible with like every database, right? You have SQL. You know how to write SQL, but also writing SQL like in a lot of ways like kind of sucks, and also gets very painful when you have structured data, right? Like you can list out like 10 columns in the database, but SQL traditionally, like for decades, even when Mongo came around, has been written for like very flat data structures. So all you have is really like, okay, is field 1 a string? Is field 2 an int? And like a little more structure than that, but any kind of nested structure becomes really painful. If you have maps, if you have arrays, things get really hard. And then one thing about BAML as well is that we have union types. So you get to shove, much like ClickHouse does, dynamic types. You can shove data of different types into the same column. And once we have type information there, we can go and allow users to define their own queries that go through BAML and then get translated into a ClickHouse query for our underlying storage layer. But from the user's perspective, like they don't really have to worry about it. They get to do like a very traditional like, reflection style query, like saying, I only want the rows where the type of that name output was a string. And in this example, right, you'll notice that we have, remember from the earlier demo when Vaibhav was going through, we started A with name as just a string, and then we broke up name into two different fields, right? We broke it up into first name and the last name inside a name object. And so what we can do now is like we can actually narrow the type and also group the type based on all the different versions of the function that you have in your history. So instead of going into Datadog, choosing all the different version hashes that you have, like version 1, version 2, version 3, grouping them all yourself, and then filtering again to strip out the ones that you care about, you can go and just say like, okay, I want to look at everything, but I only want to look at the functions that satisfy like these type assertions. And in addition, we can give you autocomplete. We can give you, if you go back to the previous slide, type hints about like what your types actually are, so that you know, like, oh, if I want to do dot access, I'm not just guessing about the fields inside the model, right? Like, we've all been there with, like, just like, we're writing Python or JavaScript to like handle some random like JSON blob or like a dump of CSV somewhere, and we're like, I can't remember what the name of the field in this row is. And if you have autocomplete, you get to stare at it right there in your browser. You don't have to flip back and forth between two different windows. And again, like once we have that information, we can give you dropdowns about the nested data types. And in addition, what we can do is we can also, because we know that there are dropdowns, one thing that gets particularly complicated if you have nested types, particularly arrays, maps, and objects, is that flattening that data also gets really complicated. And there are things that we're going to be able to do with that. And in addition, like once we have types in our own SQL dialect, because we let you do that type refinement, it gives you a lot of power. And we also get to just actually blatantly tell you, without you having to do a round trip out to a database and be sad when it fails because like you forgot to add the password in the environment variable and then you find out the error, then you get to see that, okay, I know that this is wrong and that this won't work even if I can still execute the query. On top of all of that, we can also hand back all the output results in the format that you want. If you want it in a Parquet file, if you want it in an Arrow file, Avro, Pandas data frames, like whichever format you want. Some of this will probably also actually literally be able to just like farm out to ClickHouse itself if user wants to do like aggregations or something and just like store them in like file tables in ClickHouse themselves, like with aggregation pipelines. But the types will allow us to do a lot, and letting users go from like bounce back and forth between different windows or like spend like minutes on iteration cycles and just see it right there live. And every single time we talk to a user who's been using BAML for more than like a few days, the thing that they consistently tell us they're surprised by is just how much they get to stop thinking about. They don't have to spend time and energy worrying about like, oh, I have to like twiddle with like braces or quotes in like this specific place. It just takes care of that for me. And being able to propagate that carefreeness and allowing people to focus on the problems that they actually have, their business problems, is a large part of like why we've done all of this.
Awesome, sign me up.
I'll stop. The whole premise of this is we started with a really, really simple question. What happens with types? What happens when you have type safety? And I think so far, two beautiful things have happened in my life, TypeScript and Rust. Wouldn't be possible if they didn't support the type safety we have. And clearly, these languages have had decades of development on them. I guess in terms of TypeScript, a decade of development on it. We're trying to go further and say, what happens when you have types somewhere else? How can we take out prompting, vibe programming, and bring back engineering so we have reliable, maintainable pipelines, not just in our code, but in our data? That's BAML. We have a fun team behind it. If you're curious, this is LinkedIn. This is GitHub as well. Like I said, it's open source. And then I think the only last part that's worth mentioning is how all of this is actually possible. So under the hood, all this is we use the JSON type that ClickHouse has, which is still in experimental mode.
Currently it is in beta.
Oh, okay. It's been updated. And then it allows us to write really, really fast queries, because what we do under the hood is we decompose from a user SQL or a user query into a ClickHouse query. And we can do that because we have you as a user were gracious enough to write code in BAML in a compiler that we can read and understand. So we read this file and we can interpret it over time and reversion and everything for you over time. So that way we can tell the difference between different versions of your data models and your code. But then, sorry, one last thing. My brain is tired. It's a long day. All of this just came together this morning at about like 2 p.m. So it was kind of surprising that it worked. I think that's it. Thank you guys for listening. Questions or anything else?
You said it's open source?
Yeah, BAML is completely open source. Always will be. No network dependency at all.
How do you make money?
How do we make money? We charge for this kind of stuff. The database is what we charge for, database access on top of this.
Okay, so the database is always cloud served. It's not locally served.
We do not yet have a way to locally serve it. Like I said, this thing is running on, I'll show you the URL that this runs on. This runs on that URL. This is not live yet. It will be live, I guess, sometime next week probably, or the week after, but we've been testing it.
Have you tested it with small language models?
Oh, BAML's been alive for over a year plus now.
No, I mean small language, and not LLMs, but SLMs.
He's speaking like
Oh, yeah, we've used, you can use any sort of language model with it. So we have people using 1B models in production.
Really?
Yeah, so, and it only works because the model now doesn't have to output perfect JSON. And in fact, if you do other problems like generating code snippets, I wish I could do it, I might have a,
we actually very deliberately were testing with Phi in like the early stages of the parser. One of the things that Vaibhav demonstrated, right, was that resilient parser. Like if you take quotes out of the JSON, like every JSON like formatter or like linter will yell at you if you even just take away like if you even just have trailing quotes in there. Just so incredibly annoying. Like
so watch this. In this code sample, what I'm having the model do is generate some code. Now, and I'll zoom in a little bit. So imagine that I was writing code. And I wrote code like this. And I had to put in JSON, right? Def print hello world /n. This is hard for me to write. Right? This is like impossible for me to write. And the more complex that this code gets, the harder it becomes to write because escape characters are the bane of existence when you write code. If you took away syntax highlighting, us developers couldn't write code for shit. I can't. I take away autocomplete, I'm pretty much useless anyway. I think I type at like 15 words per minute without it. But now what we let the model do is we let the model, again, it's about the expressiveness of English with the structure of code. So the model can output whatever it wants. In this case, it outputted some facts. Then it started outputting code, but it put the code in a markdown snippet right here. Not even close to JSON. But I think you can see how the model is more likely to get this right if it's outputting it this way than in a string with quotes and escape characters for new lines and quotation marks everywhere. The quality of the code will just be better. And the beauty is, when you're done and you're looking at the results here, guess what? All that gets stripped away and all you get is the code object. Because what you said in your code is this thing is a thing that is a code which is a string, and you just told the model to output it in backticks. So it works with almost every model.
Awesome.
Just a quick question on the logo. I have to ask about the logo on the shirt.
Oh, why lamb? It's a lamb because BAML. And lamb and BAML have the same letters. All right. Thank you, folks.
Thank you. Excellent.